All right. So this morning, before we get started with SciPy today, I am going to see if I can take a quick pass at updating our rescaling vertices pull request. So let me take a moment here. The issue that we run into a lot when we're dealing with adaptive mesh refinement data, for instance, is that we have different grid patches that can be very, very different in size and scale. What we want to be able to do, because on the GPU we tend to do everything in 32-bit floats, we want to be able to extract regions and then scale them up so that they're close to 1, so that our differences are low, and so that we can sort of exist inside a relative environment that's doesn't have large dynamic ranges. So what we want to be able to do is pull data out, rescale it so that it fills our world coordinates, which we can leave as standard, and we can have our clipping plane be something meaningful, our near and our far planes and so on, have them all be sort of relative to a set of scene coordinates. What the reason that we run into issues with this, though, is that we often will have situations where we're relying on world space coordinates to do things like compute the distance that a ray travels through the scene or something like that. So a while back, I made an attempt at rescaling all of our vertices as they go in. Now, this was quite some time ago, and I will show what that looks like right now. The original code, and it looks like I did this back in November of last year, the original changes were essentially to set a uniform that was a view matrix that has been matrix multiplied by a scale matrix, and then setting a scale matrix that attempted to scale everything between 0 and 1. So what we're going to try doing is we're going to try to update that for our current set of code, and we are then going to see if we can make it work. What I was running into is that scale matrix, which was only really applied to the blocks, wasn't being propagated through into the camera, and we're getting a lot of really weird things. In the interim, we've done a lot of different changes to the way that we compute, for instance, the position of the rays and so on, and so it's entirely possible that we now will have that working. Now, one last thing I want to do before I start this, though, because I'm going to be merging, last night I did a few more changes to the particle point rendering. I'm going to go ahead and merge that. So now, when I pull from main into our rescale vertices, it looks like we've got a conflict inside blocks. Let's take a look at that. I'm actually not super used to the VS Code method of resolving conflicts, so this might take a moment. So let's see. In head, we've got scene camera. So it looks to me like the incoming change just gets rid of everything. And so what I'm going to try doing here is I'm going to say we're going to accept the incoming change. Now let's go over here to our changed. No, I don't. Are there other merge conflicts here? Oh, I have to save it. Okay. This has unsaved changes? I don't think it does. Save all, commit. idea, but I guess we'll see. All right, so what we've done now is we have computed the scale matrix. So inside our block collection, you'll see we now have scale matrix. By default, it's set to 1. And here we've got our scale matrix, and we've added it by translate. And what that should do is it should apply both a scale matrix and a translation matrix. So let's see what happens if we do this. Now, previously, we've had our scale matrix defined on the data object. We're going to go ahead and make that part of base component. So base component, everything will have a data. We're going to set a property for the scale matrix. And it is going to defer to the data. Now we're going to take this scale matrix and we're going to put that into scene data. So now it should be present on all of them. So we look back over here at pull request 1. Looks like we don't have a specific example, but we should be able to do any of our volume renderings. Let's do our subset sphere. Make sure that subset sphere does what we want. What subset sphere does is it creates a sphere, center 0.1, isolate a galaxy, and it passes it in. Now we're still not passing the scale matrix in, so in principle this should just do a bunch of rescaling. There we go. So we're still getting our subset sphere because we're not doing anything with our scale matrix, and we're not even modifying anything of our incoming data. So now what we should be able to do is we should be able to go into base camera, and here self.view matrix, we're going to at against scale matrix. So one of the issues we've got here is that we're setting these uniforms, and we now have this projection, this view matrix, our scale matrix. What we're going to want to do is we're going to find all occurrences of this. Let's refactor. Oh, I forgot to change the scene. This one is not going in the archive, I'll say that much. Oh my goodness gracious. Well, I guess you couldn't see anything that I was doing. Ugh. Just me talking, because I was only on for 11 minutes. Okay, so this is what it looks like. So now let's see if we can get our view matrix. And now let's do Scale matrix. Vertices, some kind of fish. It's a good question. So vertices here is, scaling vertices. That's a good one. I like that. So the vertices here represent the boundaries of our grid objects. So let me see if I can show that a little bit more clearly. AMR volume rendering. What I'll do is I'll pull this up and I'll describe what the different vertices are inside this. Oops, invalid syntax. Yeah, I gotta get rid of this. Let's save that again. So this is our full set of data, if it ever comes up. And this is composed of all these different grids. So each one of these grids that you'll see is a three-dimensional object, and they're defined by a set of 8 vertices. What we want to be able to do is we want to make it so that if we're only looking at a subset of them, that it scales it out so that we're not dealing with really itty-bitty numbers, for instance. So we're going to see what we can do about rescaling all those vertices. So here I'm going to take scale matrix. Oh, one, I guess, thank you. I don't have a turtleneck on, but you know. So if scale matrix is none, scale matrix equals np.i4. So that'll give us a good default value. And what we're going to do here is we're going to go back to our base component, and it's going to see, we've got this scene self.camera, self.scale matrix. So that should default back to I, and let's see. This should give us the exact same thing we saw before. It's a good question. So let me tell you a little bit about this. This is a simulation of a galaxy forming. And what we want to be able to do is we want to be able to, did I not save that? We want to be able to explore that galaxy forming and examine, for instance, how we want to be able to look at that galaxy forming, and we want to be able to identify, for instance, where stars are likely to form, how gas outflows happen, and so on. But it can also be used for things like simulations of weather in order to identify characteristics of deadly tornadoes and things like that. That's another thing that's been I don't know that I'm the one making the simulations. I mostly work on simulations of the past when I do this stuff. My work is all largely around the way that the first stars in the galaxy formed, or first stars in the universe formed. There's somebody else in the chat though that looks at, let's see, what is it that you study again, Clement? Is it planets, something like that? I can't remember. So let's see what happens if we do this AMR subset sphere. Here, it should be applying a scale matrix. Let's see. If it did the scale, no, it didn't. Oh my goodness. All right, so let's see. Got this self.data. Oh yeah, protoplanetary disks. There we go. So this scale matrix sure isn't working. So let's take a look at this self.data.scale matrix. I thought we had it set up right, but I guess we didn't. Let's take a look. Come on, show me the scale matrix. Yeah, it is doing a neat little scale matrix there. It should be scaling it. Every time we do it, it should not change. So let's figure out what's going on with this. So over here inside our camera, we've got our project. Oh, because we're not doing anything with it. At scale matrix. So that's a great question. Is this a passion job or for a job? So kind of both. So I'm a faculty member at the School of Information Sciences at the University of Illinois, and I actually was trained as an astronomer, and I did computational simulations. And so a lot of this stuff is stuff that I do for my job, but I have to say that the reason that I'm really into what I'm up to now is because I really like doing it. I love it. So yeah, I guess it's a little of both. So now we're seeing the issues. Look at that. You can see the little bit of stuff here flickering off at the edge. You can see where we're getting boxes. So I'm going to guess that we are not setting this correctly. We've got this view matrix and our scale matrix. So let's take a look at our scale matrix definition. I don't know. I think it's fun stuff, and you can still think no matter what, we can still chat, have a good time, whatever. Let's take a look at our base component and take a look at our scale matrix. Blocks.py, that's a scene component. Where am I setting my scale component? Oh, right. Block collection. So we've got our scale matrix. This is np.i times scale times translate. You know what? Let's get rid of that translate. See what happens if we do that. Oh my goodness, no translation. But look at that. It does look properly scaled. Now there are some oddities with it, and I think those might come down to the clipping plane. But it is definitely scaling. It's just not translating it to the correct position. Now one thing that I always get mixed up with this stuff is I always get mixed up with the right order to do these matrix multiplications. Let's try doing our matrix multiplication in the other order. Translating, is this scaling then translating? Do I want to translate then scale? I always get those mixed up. Well, it actually looks like it didn't matter that much. Probably, oh, you know why? It's because this is diagonal matrix. Okay. All right, so now we're stuck at this position where we've got translate minus right max plus left min divided by 2. What happens if we do that positive instead? I only know an itty-bitty bit about neurology. I will say that the software that we're using right now has been used for visualizing MRIs and brain scans and things like that, but it's been a while since we did that. One thing that we actually, you know what? Why don't we try? Let me see if I can do this. Yeah, there we go. All right, I've got a DICOM scan here that we can switch out to use. So we'll do. Let's do this one. No, let's data 1.9. All right. So here, let's go over here to AMR volume rendering. And let's load up our DICOM. We can look at a brain. So here, import h5py with h5py.file home enteric dicom.h5. Oh, Yeah, I do. I've seen The Matrix, actually. There was that that whole scene where they just did that. Uh, let's see, 019. So let's do load uniform grid. We'll just call this density, even though it's not density. Dims equals 36, 512, 512, and then we'll say vbox equals np.array. I'm going to have to import numpy. 0.1, 0 0.0, 0 0.1, or sorry, 0 0.0, 1.0, 0 0.0, 1.0, 0 0.0, 1.0. And I think I might need to transpose that. Yeah, let's try this. Back on volume rendering. Oops. Let's take a look. Oh, I thought oops. See if we can get a brain up here. Yeah, there we go. We're going to have to zoom out a bit. Oh, you know what? Let's get rid of that whole scale and whatnot. Because that whole thing is just messing us up. Alright. So now we've got a brain. Let's see, let's go in here. Block rendering. Let's do projective integration. That should do it. Reset our color bounds. Let's not take the log. If I can get it to uncheck. I guess let's go back to maximum intensity and reset our color bounds. Wow, I'm not happy with this. I was really hoping to get a cool brain up there. That sure is disappointing. Alright, let's do sg.components 0 dot let's see, what is it, log. So we can use just about anything. The one that this particular scan is an MRI. It's there we go. Yeah. Now this is a little bit slow, you'll notice, and I think that's a function of the aspect ratio. There's some calculations about how many times to take the ray step through the volume that are dependent on the aspect ratio of the data. And this particular data set, there are fewer slices along one direction than the other, and I think that's confusing the ray calculation. So it's probably taking way more steps than it needs to. but you can just about make out the brain. There's face, brainstem, and so on. All right. Now let's see if we can. Now what was I? Oh yeah, we were working on scaling. Let's go back over here to our base camera. Let's toss our scale matrix back in. Oh, really? Oh, that's super cool. Did you come up with anything? Yeah, that's how it always went for me. All right. Now, I'm starting to think that maybe the issue here is that I'm using the same matrix for different things. So let's try out passing in a new uniform. Shader program dot set uniform scale matrix scale matrix. And so this is what they typically do. This, I think, is what's called the model matrix. So let's take, hello, let's see if we can now go into our known uniforms. We'll add our model view. We will go ahead and we'll add uniform mat4 scale matrix. And now here inside our grid position vertex, you'll see we've got this whole model vertex here. The inverse projection, inverse model view, inverse projection model view, and all that stuff. What we want to do, we've got this in left edge. Let's check over in our geometry. So we're not doing much here. This the model vertex that we're passing in, if I'm remembering correctly, is just like a 0 or a 1 or something like that. Because we've now got our expand inside our vertex matrix. And our new position ignores it completely. Yeah. We just pass out the new position here. So let's figure this all out. Now, our V model, that is our vertex model. Let's scale matrix times that. And that should work out just fine, because now we're expanding it and we are modifying just the position. We're not modifying anything about the camera, we're not modifying anything about the left edge and the right edge for the purposes of ray tracing. No, it's still not quite working. Ah. Yeah, I actually know very little MATLAB or Java. I've written a tiny bit of each of those, but not really enough to do anything. So I think what we're seeing here is we're seeing that my modifications totally did not work. Yeah, I don't really know what makes a slot machine fair. Is it that it has equal chance of landing on everything? Okay, so now we're multiplying in the right way, in the sense that this seems to be the center, but the translation matrix is happening at a funny place. So let me go back here and take a look at my diffs. Base data. Yeah, we definitely want to commit that one. Probably want to commit that one. Yeah, I'm going to have to commit that. But let's take a look at block collection. Back here. Oh, I guess I didn't change the order of anything. So I'm going to go ahead, commit these, because I do like where we're getting to with some of the ordering, but I think I'm going to need to back up and work through this in order to get all the different matrices modified in the right order. Move scale to base class. Oops, onstage files detected. Show command log. Looks like base data. Let's see, get status. Oh, there we go. Base data. Block collection. Base camera. So it changed up. My pre-commit hooks changed things. All right. I'm going to go ahead and push this up. Rescale vertices. It's going to fail all my continuous integration. And yeah, if we go over here, we can refresh. See that we're now changing more things. And that's about all I can do right now. So I've got to go to a conference, but really appreciate y'all coming here and hanging out. Hope to see you again soon.